Let's talk about balancing chemical equations. And we're going to use the law of conservation of matter, in that the number of each type of atom on the reactant side has to equal the number of each type of atom on the product side. The atoms can rearrange to form new compounds. Atoms cannot change identities to make new elements. And Dalton was the one that told us about that back in his atomic theory. We're going to have subscripts and coefficients. We cannot change subscripts because now we're changing the identity of the compounds. We can change and must change the coefficients in order to make atoms balance. And so let's look at this reaction. H2, that's a gas, plus O2, that's a gas, reacts to make H2O, that's a gas. Molecular hydrogen, H2, plus molecular oxygen, O2, to make water. And I've just specified the states of matter. You don't always have to do that. I'm doing that to give you some practice in hearing this and seeing this. So we want to make sure we got the same number of each type of atom on both sides. So right now I've got H2, I've got two hydrogens on the left, and I've got two hydrogens on the right. The subscript multiplies whatever is in front of it, the element that's immediately in front of it, in both instances. I've got two oxygens on the reactant side, but now I've only got one oxygen on the right. I cannot just stick a 2 after that oxygen in the water, because now I'd have changed it to H2O2. That's a different compound. That's hydrogen peroxide. If you want to drink lots of water, you need to keep well hydrated, but you don't want to drink any hydrogen peroxide. That'd be bad news. So I need to increase the number of oxygens on the right-hand side. So to do that, I'm going to change the coefficient. It's understood that there was a 1 in front of each of these to begin with. Then I'm going to put a 2 in front of that oxygen, in front of the water. And so now I got 2 times 2, and then I go to 4 hydrogens, and I've got 2 oxygens on the right-hand side. Go back to the left-hand side, the reactants. I've now got 4 hydrogens on the right. I need to bump up the number of hydrogens on the left side, the reactant side. So I can't change the subscripts. I can't change the coefficient. So I'll put a 2 in front of the H2. So now I got 4 hydrogens. And 2 oxygens, 4 hydrogens, 2 oxygens. That's a balanced chemical equation. We mentioned H2O2 just then. So let's see what happens when H2O2, hydrogen peroxide, decomposes. It can decompose to make water and oxygen. Now the first reaction, we took 2 compounds, H2 and O2, and reacted them together to make water. And that's a type of reaction that we could call a combination reaction. This reaction, we're taking a single compound and breaking it apart, we call a decomposition reaction. And knowing the name or types of reactions sometimes can help us understand what's going on. So let's balance it. To balance it, we have the same number of each type of atom on the reactant side and on the product side. So H2O2, 2 hydrogens, 2 hydrogens. So far, so good. 2 oxygens on the reactant side. Look at the product side. I've got 1 oxygen in the water and 2 in the molecular oxygen. So now I've got a total of 3 oxygens on the right-hand side. So things are out of kilter. I need to change my coefficients in order to balance this chemical equation. So right now, remember, I've got 2 hydrogens and 2 oxygens. Over here, I've got 2 hydrogens and 3 oxygens. I need more oxygens on the left side. So I'm just going to bump this up by 1 increment. Instead of 1 H2O2 on the left-hand side, I'm going to put a 2 there. And that coefficient, that's what we call the number out front, will multiply everything after it by 2. So now I've got 2 times 2 are 4 hydrogens, and 2 times 2 are 4 oxygens on the reactant side. That's not a 0, but a O, capital O for oxygen. Now on the left-hand side, I've got 2 hydrogens, so I need more hydrogens. Let's bump that up. I'm putting 2 as a coefficient in front of that. So now I've got 4 hydrogens in the water. H2O, so I've got 2 out front, so it gives me 2 oxygens from the water, plus 2 oxygens from the molecular oxygen that's out here. So now I've got 4 oxygens on the product side. So 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens, and everything is balanced. It's a trial and error method that we use when we balance chemical equations.